Hello, in this video I will show you how to use this dynamic group of properties, and this is a property which allow you to define how your particles will be moving during their simulation and rotating. So first group of properties is speed, and this is a random value which will apply to their particle speed. And well, I will have this three examples here. First one using low value 1, and it's exactly the same for minimum and maximum. So you'll see the difference between this 1 and 5. In this case, I'm using the same value of 5 for the second example. So you will see the difference between this first one and second one. And in the last one, I'm using variation from 1 to 5. And it's always better to use some variation from low value to high value, so your particle simulation will not look exactly the same for every particle. Again, let's take a look. So here you can see in this first example, it's a very boring simulation. They basically are not moving anyhow. Just let's take a look closer this time. It's just emitting some particles and they just start falling down, nothing special. And the second example, we have much more explosive simulation. You can see that they're kind of explode to all direction, which also looks weird maybe in case you have this high speed value for every particle. And finally, in the last example, I have some variation. So some particles just fall down and some particles explode. And again, as you can see, this example with some variation looks much better than the previous two. So this is how speed property works. And next example shows you this inherent velocity property. And if speed is just random speed which applied to every particle towards its direction, in case of inherent velocity, it will use actual object which emitting the particles to use its velocity, and it will apply this velocity to particles. And again, I have these two examples. First one has 0 inherent velocity, which means it will not use fragments velocity at all. In the second example, I'm using this pretty high value too. Again, I have minimum and maximum value exactly the same. And in third example, I'm using some variation from 0.5 to 1.5. And again, let's take a look how it looks like. So here you can see I'm start emitting this particle during while this fragment is falling down, and every fragment emitting some particles, and they just whenever they appears, they just start falling down. Also, I want to mention that for all those examples, I'm using speed to 0, so there is no any random speed. Any speed they can get is only thanks to the fragments velocity. And again, you can see when they appear, they just start falling down. They don't have any kind of velocity at all by default. They just start falling down while the object falling down. In the next example here, I'm using high inherent velocity property here for minimum and maximum. Here you can see, so when this particle appears, they are just shooting towards this fragment simulation. Let's take a look again. So here, let's take a look. Like this particle here, you already see that it starts moving with speed which twice higher than the speed of the fragment which emitted this particle. So you can see that some debris, they start moving even with higher speed than the actual fragments, and in some cases it may look okay for you. In some cases this looks weird. And the last example here, I'm using this variation from 0.5 to 1.5. And again, this case looks much better because they all have different speeds. Some of them just start falling down, and some of them already have some velocity. So this is how inherent velocity group of properties works. Next group of properties is pretty straightforward. It's gravity. And this is multiplier for physics gravity. So again, you can set minimum and maximum value. In the first example, I'm using minimum multiplier value 0.1 to 0.2. Next example, I'm using 0.1 to 0.5, which means that some particle will have low gravity and some particle will have big gravity. And the last example show you the average properties, which is default properties. So some particles will have slightly lower gravity than the physics gravity, and some of them will have slightly higher than the default physics gravity. So let's take a look. Here you can see these fragments, this debris slowly falling down, and in this example I have debris which fall to the ground very quickly and some still falling down pretty slowly. Let's take a look again. Here you can see some already get to the ground, some still falling. So again, the best way is just to use some variation instead of having the same property, but this depends on what kind of material you're using for your debris. So let's say if it is rock, that's obviously need to use higher properties of gravity, and if this is some kind of splinters or maybe some leaves, then you can use lower value for your debris. So this is where you can define gravity. And finally, last group properties here is rotation. And again, here's my rotation is very set to 0, which means that particles will not rotate during their simulation. They'll be basically will be static. And in this example, I'm using this average value 0.5, and final third reference I'm using maximum value of 1. So let's take a look at this first debris. Just let's take a look at this one. As you can see, while it's falling down, it has this fixed rotation. It's not rotating anymore, and there are no particles which rotates. It just appears at with some rotation and fall down without any kind of rotation. Again, in some cases you may need that, but I guess this looks weird a little bit. And in the second example, I'm using some rotation 0.5. So that means that some particles will rotate during their simulation. Okay, you can see that this big particle, it's slowly rotating. And for the last example, I'm using very high rotation speed value. So some particles here will have very high rotation velocity. Here you can see they're spinning like crazy, some of them. So this is where you can define your rotation speed, so they won't look like static, just fall down without any rotation. Okay, so that was dynamic group of properties, and thank you for watching.